I'm Ryan Jeffrey, and this is the Passionate About OSS podcast. The purpose of the podcast is to shine a light on the brilliant minds in the OSS and telco industry, and to describe some of their background, but also to share some of their knowledge, tips, and techniques with you, the audience. Today we'll take a look at a solution which is a hybrid approach, off the shelf and open source, that's used to tackle the network assurance challenge faced by service providers and enterprises alike. Today's guest has been building OSS since the late 1990s. These products were originally built on legendary open source tools by Tobias Edeka, so the RRD tool, Round Robin Database, and MRTG, the multi-router traffic grapher. Our guest's solution helped to fill some of the gaps in the front end, i.e. the web interface, and the back end, the device pollers, left around Tobias's tools. What was initially a side project whilst forming a career working for network leaders like Cisco and Anixter eventually turned into something much bigger and something that is running quite strongly today. So our guest is now CTO of a thriving OSS business and a business-focused innovator. And you'll find that his roots in SysAdmin and Network Admin will come through loud and clear in the conversation as well. I'm really excited to trace his journey from those humble but really important beginnings for the network community through to the role that his company continues to perform today. So welcome to Keith Sinclair.
Ryan, thanks so much for having me. It's a pleasure to be here.
Pleasure to have you on. So Keith and I first connected all the way back in 2012. I was due to visit a good friend on Australia's Gold Coast, who also happens to be a gun OSS developer, interestingly. Then somehow that same week I heard about this thriving little OSS company that was also based on the Gold Coast named Opmantek. Probably to the chagrin of my wife, I decided to take a brief interlude from the holiday to meet up with Keith's business partner and chairman, Danny Ma. And Danny subsequently introduced me to Keith. There are many places that OSS are developed globally, but the Gold Coast is a little bit off-Broadway. We'll cover a bit more about the Opmantek journey later, but why the Gold Coast, Keith, as lovely as it is?
I would argue that NMIS wasn't developed on the Gold Coast. I was actually living in Sydney when NMIS was born. So NMIS was, I'm a Queenslander, I was born in Queensland, and had moved to Sydney as many ambitious young IT engineers were prone to do, especially in the 90s. So I ended up in Sydney working, doing my day work and seeing the need for this open source thing. I wrote NMIS back while I was living at Sydney. And then, you release things to open source and they have a life of their own. So off it went, right? So, and then go through the time and there's developers from New Zealand, Eric from New Zealand, and guys working on it from all over the world. A lot of guys in Europe obviously big into open source, a lot of European guys involved. And so then fast forward to when Opmantek started, Danny and I were actually living in Brisbane, and Danny wanted to do this sort of open source. Well, I suggested an open source project, and that's sort of where Opmantek came from. And then Danny was sort of saying, I might move down to the Gold Coast. And I'm saying, well, I like Brisbane. I'm staying in Brisbane. So Opmantek's at the Gold Coast, but I have always lived in Brisbane since I moved back from the States in 2004. So I spent a lot of time driving down to the Gold Coast and back, and the offices at the Gold Coast, because Danny felt that was a nice place to be. And we had this sort of idea that people would rather come to the Gold Coast and live there. And that's kind of true.
Yeah, hard to argue, isn't it?
It's really easy to hire people from Melbourne who are sick and tired of the weather in Melbourne to come live at the Gold Coast.
Absolutely. And your systems and network administration journey goes back 2 decades before we even met. Are you able to describe a little bit about those early days and what they entailed?
Yeah, so I was studying computer science at uni and using Unix as you do. Back then you did. Everyone used Unix, and it was pre-Windows being usable. And of course you had all the graphical workstations, the X-terminal graphical workstations. So, and they were expensive. So universities could afford them and most businesses couldn't. So yeah, I was using a lot of Unix back then, and I quite liked it. And my brothers were actually into it. One of my brothers studied computer science as well. And at any rate, so I was at uni doing computer science, and they actually stopped the computer science project and said, we're going to stop that and do these majors. We're going to introduce data communications as a major. And by then I'd had to stop going to uni full time. I was going part time, and I was working in a building society, and I'd started administering a Unix computer for them, an AI Xbox. And I'd started playing around with networks, because that's part of SysAdmin is networks. People forget that network admins do sysadmin. It was the same job back then. So basically I was doing the Unix sysadmin, and I was responsible for the network, and the uni said, we got to do data comms. So I became a data engineer, right? Like a Unixy sysadmin-y networky guy, as most of the early networker guys, a lot of them were. And so that's kind of how I ended up being a network engineer. And that's how I ended up, in 93, I started playing around with Unix professionally, and then configured my first Cisco router at the end of 1993, somewhere towards the end of 1993.
Mm-hmm. And then you had roles at Datacraft, Anixter, Netstar. All some interesting things would have been happening at those organizations.
Yeah, so the internet was booming. So while I was at the Building Society, this is Ipswich and West Moreton Building Society that got wrapped up about 6 times and bought and acquired and merged so many times, and it's now part of Bendigo. That original organisation is now part of Bendigo Bank. So a huge bank now, one of I think it's the 5th biggest bank, I think, in Australia. But that was, back when it was a small building society in Ipswich. And I learned everything there. I really learned so much doing that role. I learned all about networking. I learned all the basics. I actually configured Windows. We had Windows desktops by that stage. We had Windows NT. It was just an absolute wealth of knowledge that I gained. So I really think I had, probably equivalent of five years or more experience in the 3 years that I was at the Building Society. And I got lucky, right? I was just doing Unix, and I learnt Cisco, and I was doing X25, and I was building WANs, and just doing all this stuff really, really early. We put Craig Lawson and I, who's a Gartner guy now, Craig and I put the first website up for a built financial institution, back in 1994, like on the internet. We had a website on the internet for the Building Society. So basically,
before the days of content management systems, and then with all of the networking and sysadmin before the days where it was all plug and play. So
this was handcrafted HTML written by us, simple website, 4 or 5 pages. And it was just, that's what we did. We talked, and we had email addresses, and we did all that stuff back in the 90s. So I got really early into the internet. And so then the jobs just came, right? Like I got asked to go to Datacraft, and then I got involved, from Datacraft, I went across into Anixter, and then Anixter became Netstar. I actually only worked for Netstar for about, not very long, like maybe a month or something, as a sort of that company was formed, and I moved on. Then I worked for Macquarie Bank, and then I went to Cisco, sort of in a pretty quick succession. That all happened within, we're talking 5 years. I think that quick transition, which was really normal at the time, to sort of do a role for 2 to 3 years was kind of normal. So, I was lucky to be early on into the internet, got into, Datacraft, and then through to Anixter, and then into Cisco. And I was building networks for people. That's what we're doing at Anixter. I was down in Sydney, and I was installing, I installed a backbone router for ARNet before I even sort of realized what ARNet was, right? It was ARNet was tiny back then. Anixter, they paid Anixter for the box. And this is a big Cisco 7500 series. This thing cost a fortune. The blades were worth more than my car. It's just so massive box. And here I am learning Cisco, but learning more about Cisco all the time, and plugging it in, then ringing friends to find out things about how to do certain things with 7500s. And these are fault tolerant kind of systems, right? So hardware failover and all this sort of stuff that you're just learning all on the fly. And it was great. So I was very, very lucky, ridiculously lucky, to just get exposed to all of this stuff early in my career. I was 25, when I became a pre-sales engineer with Datacraft. Crazy. Like, I was at CCIE at 27. It was just really lucky. There's this wave of internet just coming through, and I was happy enough to be, standing on the front leading edge of it. It was really great experiences.
And you must have been CCIE number 12 or something like that in those days.
No. So I'm only CCIE 3117. But now interestingly enough, they started CCIE numbering. The lab for CCIE was 1024. And when I was based in California, one of the guys I worked with, his name was Stuart Biggs, and sadly he's not with us anymore. And Stuart Biggs, he was very modest. He didn't say very much, and he was a really quiet guy, super intelligent and really sharp. And he sat next to me, and we'd often go for coffees, and but he never met, and I knew that he was involved in CCIE. I knew he was the first CCIE. So he was the first CCIE at 1025. What I found out later was his idea. He started the entire CCIE program. He told Cisco they needed it. He said that you need an education. It was all his idea. He started the whole program, and the guy used to sit next to me. But I didn't really realize that.
The program that spawned the million sales arm without Cisco having to pay for all of those salespeople who go out and spruik and include Cisco products in their offerings.
Right. But Cisco's approach has always been something that I've been and networking companies in general have followed this trend, is that Cisco was very much, here are the standards and the protocols that you need to be successful. These are the standards and protocols and methodologies you need to get your business doing what it has to do. And here's our products that implement them. So multi-protocol interoperability was massive back then. And this is something we've lost in the industry in general. Interoperability is just absolutely key. So I buy a router back for companies that people may not have heard of, but I buy a router from Wellfleet, and I buy a router from Cisco, and I get them to talk together on an Ethernet segment. That's what we used to call them, Ethernet segments, with coaxial, thin net. And we'd put them on a segment, and then we get them to talk OSPF together. And sometimes it wouldn't work, and you'd have to raise a bug, and one of the vendors would fix the problem, and you'd be internetworking, multi-protocol, multi-vendor internetworking.
That's what you had to do to get it to work. And tell us a little bit more. So a lot of the listeners are probably not familiar with what AARNet is.
AARNet, I got to remember what that stands for. So it's Australian Academic Research Network.
Effectively the network that interconnects all of the major universities here in Australia. And Melbourne Uni was the issuer of domain names here in Australia. So they really led the wave of internet here in Australia as well. So AARNet was a really big thing, particularly back in those days.
That's right. So you would have, by that stage, you could actually get dial-up internet. They would usually have a cross-connect to AARNet. And then it was sort of, Telstra was building out some infrastructure at the time. But basically, AARNet was the backbone that all the universities did. So when you were sitting at home on your dial-up internet, you'd be doing something with maybe power up here in Brisbane. We're getting to Telstra, and then Telstra would have the big fat pipe to AARNet. And you would then cross over to get to the university. Because back then, a lot of the content, companies weren't there. Your content was on was on university sites.
Absolutely.
Or it was on government sites. And it was pretty interesting. And funnily enough, with my time in San Jose, I had this crazy, weird career. And so my boss, Stuart was who I worked with, and my boss was Brad Wright, and sadly Brad's not with us anymore. And Brad was employee number 400 at Cisco, just to give you an idea. And he was the guy who convinced Cisco that they should have the company website do support stuff. So Cisco didn't have a website before he suggested it. He suggested it, and the first thing they did was put support on the website. The products came later. So he was running the TAC. He was the first TAC manager running the TAC. Stuart was actually one of his engineers at the time. So he was doing all the support stuff. And so this is back in the early 90s, maybe even the late 80s. And so they pitched the whole thing. So famously for Cisco engineers, there was a thing called Univer-CD. So you always get your latest CD-ROM with all the documentation. It was all in HTML. That whole thing was on the website, but usually you couldn't reach the internet. So you had to have a copy with you. You'd have your lab, you'd have your bag with your computer, with your console port for your Cisco router. I did a lot of work with IBM and Wellfleet and all the other vendors back then. I was at Anixter, we were multi-vendor. So we worked with 3Com and everyone's products. And I did lots of ATM stuff and 4 networks and all these different vendors as well as Cisco. You had your Univer-CD, which was your documentation CD. You'd put it in your CD-ROM drive so you could check the documentation on how to do something, right? So Brad Wright's idea was to put all of that on the internet. And that's what Cisco did. He went up and he did the entire pitch. The entire team turned up to pitch to the Cisco board wearing Star Trek uniforms, right? True story. Heard it from the horse's mouth, true story. And that's why, because then I said to him, that's why the website was called Kobayashi. The Star Trek fans out there, it was Kobayashi was in the URL, right? Was the Univer-CD, but it was Kobayashi, which is a famous thing from the Kobayashi Maru, which is a famous thing in the Star Trek folklore. So this was, all these sort of things tied together. And I finally had that answer is, why is Kobayashi in the URL? Why is that part of the URL? So,
fantastic.
The internet was huge, and we forget. It's exponential still in its growth today, I believe. I think back then the growth was faster, and it was just, you just spent all of your time just helping companies to get connected. I remember I was living in Sydney at Clovelly, and I had broadband internet, maybe 10 megabits per second back in 98, 10 megabits internet. It was amazing. And earlier I'd had dial-up, maybe 2 years earlier. All I could get was dial-up. I was very lucky to have ISDN from my work. And ISDN was incredibly expensive, but I had that for work. paid for by work. All the time I was doing all of that, I was coding and writing code, and just, at night I would just sit in front of my computer doing stuff that I didn't get a chance to do that I was interested in. So I'm interested in all sorts of things during the day, and I was studying for my CCIE during 95 and 96. I'd work all day, I'd study all night, and then I kind of got that habit of just keeping busy at night. So I just kept, by the time I was a CCIE, then I just would be writing code and solving problems and writing scripts to do things and just doing all sorts of different things. And that was what I loved, that integration. I love the ability to get data from somewhere, do something with it and make it more useful, and then do something else with it. Right. That was the thing I still love doing today, but that's what I was doing a lot of in that late 90s period when NMIS was born.
So are you able to put a finger on exactly when the seeds of NMIS really started?
I know exactly when it started. I know exactly the conversation that started it. So I'd been working at Anixter, and I built out a system for Anixter's remote management service, which went on to become but Danny took over and ran and developed a huge business out of, and it still ran a lot of the core parts of the software. And there's a lot of concepts that I put into that system, and it was around policy management, and it was around the ability to do action policies. So that the Anixter system, an alert would come through the system, and the operator would get it, and it would have a customer profile. Everything was related back to a customer and to a policy. And then a customer could define their action profile. So the action profile, for example, would be investigate for 15 minutes, then contact us. That was kind of a high level idea of what it was. So ring immediately, then investigate, right? That was kind of these simple things like, what is it that you want us to do when these things happen? And they had a policy, and they could set those. It was very flexible because a human would just read the policy and execute the policy. So there was those were the ideas in my head. And you got to remember, I'd studied computer science and algorithms and all this sort of stuff, and data and databases, and I had that all in my head. So then I left Anixter, and I was over at Macquarie Bank, and I said to my boss, he said, all right, well, the problem I want you to solve is we don't have visibility. We need visibility. What can we do? And by then I'd been playing around with MRTG a lot, and I've been using HP OpenView Network Node Manager and a whole bunch of other commercial tools, Router PM and all these different things. And I said to him, what sort of budget have I got? And he says, well, how much do you need? Being Macquarie Bank, how much do you need? I said, well, some of the stuff's not worth buying. Some of the stuff's worth buying. Should we buy everything, or should I write you something? And he said, what do you think's the right idea? I said, we should buy some stuff and I should write some stuff. So, I said to him, we'll do some open source stuff. He goes, fine. And so that's where NMIS was born. I wrote the core of NMIS and released it while I was at Macquarie.
Okay. You also chose to use RRD as well as MRTG. What was so innovative, and what made them attractive to make them worthy of building NMIS upon?
I'm going to use the term that I think Einstein used. In my mind, open source is standing on the shoulders of giants. Mm-hmm. There's all these people. So I was using MRTG before I wrote NMIS. I was using MRTG, and I liked MRTG, but it had problems that it didn't solve, right? There was things that it needed improved in it. And I'd made my improvements, and I used to be involved in the forums and do things and send emails around or whatever. I'd written some customizing scripts and tweaked it and done things and made it work better for me. And I'd shared what I changed with the community. But by then, Tobias had sort of moved on. And one of those giants that I got to stand on their shoulders was Tobias. Tobias was way ahead of his time and, super clever to figure all these things out. So he'd taken MRTG, and he'd figured out that there was an algorithm, and a key algorithm that he'd done was this data summarization solution. Mm-hmm. And I've since written these algorithms myself. It's very hard to get them super fast and executed. It's also very hard to make them flexible, extensible, and all the other things that RRD is. So what he did is he solved this problem of taking a performance database. So he took all that stuff out of MRTG, everything he'd learned, and he wrote RRD, and then he wrote the next version of MRTG to use RRD. He made an engine out of the part of MRTG, and they made a front end. So what NMIS is an RRD tool front end. That's what I wrote. So Tobias released RRD tool, and this was about the time that I'd gone to Macquarie. Like, it might have been released within months, at least within a year of me starting doing this work at Macquarie. So I wrote the original engine based on all the open source stuff and libraries. So Simon Leinen is another European fellow, and he'd written the SNMP libraries. So basically, I sat there at Macquarie and said, well, what do I need to write this thing? Well, I'm going to have to do it all with open source stuff. So I went, right, RRD tools there. Great. What language will I write it in? Because at the time it had Java stubs and everything else. Like, it had lots of stubs that you could use different languages. Python didn't exist at this point, but there were lots of languages you could use RRD tool with. So I looked, and I'd obviously done a lot of Perl already. So I just went, well, Perl looks good. Simon's got a really good looking SNMP library. And got to remember, SNMP was still pretty new at this stage, 1999. It was still very new. So I just grabbed Simon's library, and I grabbed, Tobias's stubs for Perl, and I started writing some code. And that's sort of, so NMIS is not MRTG at all. It's just uses RRD tool. So you grab the database, you install the database, and then NMIS controls all of that through the APIs. There's no MRTG in NMIS. It's just NMIS using RRD tool.
So there's still traces of RRD tool there today?
There's not traces. You install, to make NMIS work, you install RRD tool onto the server. It installs the binaries for the library for the system, and then you have the API stubs are in NMIS. When you tell NMIS to do something, it's talking through those API stubs into RRD tool, the engine, the binary, and it's doing what you want it to do.
Wow.
And then you can go to the command line and run RRD tool and look at the data and do stuff. It's just, this works conceptually the same as most other databases. It's just a file-based database. It is a binary file. It's what we call a heavily sharded database. So every single concept is in its own file. So you have a concept. So for example, input-output traffic on a Cisco router interface is in a file. The packet data for an interface is in a file. And that means that when you want to do something, you can instantly find the thing you want. Algorithmically, you can instantly find router X, interface Y. I want to load the last 4 hours of data. Bang, I've got it. I've opened it. Right? It's instant. The downside to heavily sharded data is it's hard to do queries across all the data. But the upside is when it comes to the use case, the way people use the data, when you're looking at networking data, typically you're looking at a device and you're solving a problem at a device level. Usually today in our products at Opmantek, we do things across the network. That's a longer, we'll talk more about that later.
We'll get onto that later. Absolutely. So then by 2004, you'd moved across to Cisco, eventually to their offices in San Jose. I'm assuming that NMIS took a little bit of a backseat while you were there because of the heavy load that no doubt was happening during your day job.
Yeah, I mean, the timeline you've got there's not quite right. So I joined Cisco and had already launched the open source stuff, put it up online, and then didn't really think much about it. Just went on to do this amazing job at Cisco. In my head, I'd written some software, it was useful, and because I based it on open source libraries from Simon and others and Toby, I said, right, I should release this to open source. That's the right thing to do, is my ideology. And then I went off and joined Cisco, and then stuff started to happen. People started to ping and started to use it. And they were using the thing was people were downloading it and using it and asking questions. And, so I set up a user forum and then around sometime there, Eric Greenwood got involved and he started, adding code to it. And by then I'd put it up as a CVS and people could submit things, and we moved it across to SourceForge pretty early on. So that was sort of what was happening while I was at Cisco. So at night I'd be at work at Cisco, and then at night I'd be kind of working on NMIS at night. But I'd had an agreement with them that was all stuff that I'd done before. That was all stuff I'd done before I joined them. So then I went to the States with Cisco, and I really just didn't have time anymore. That was when I rang Eric one day in New Zealand and said, mate, I don't have time for this anymore. So he just said, no problem. And he sort of took over. He and I obviously stayed in touch and was very good mates. We'd have regular phone calls and discuss, he'd say, I was thinking about doing something or other with this new thing. And I go, oh, that's a good idea. What about this other thing? And then I was still playing with NMIS, and I always have a server lying around with NMIS running. And my brother was also involved in a short period of time, and he was doing a lot of the main admin for it. He was doing a lot of stuff with NMIS back in probably 2000, 2001. He was, he was on the forums during the day answering questions, and he was SysAdmin networky guy. It's like those rock bands that get discovered after 10 years, right? The overnight success took 10 years. And it was long tail on these things is that they're there and they get searches and people use them and they put a post up. And back then you didn't write blogs, right? You wrote web pages, and they'd add a web page to their site, and people started using it. And next thing you know, it was getting downloaded. Unbelievable. Like all the time. People were just using it all the time. I'd go to turn up as a Cisco engineer. I'd turn up somewhere and they go, "Are you guy that wrote NMIS?" And I go, "Yeah." It just had a life of its own. So that was 2000. And then in 2005, I left Cisco and went back to Macquarie. I'd had a bit of burnout from my experience in Silicon Valley, which is another whole conversation about
We'll do another podcast on that one later.
Yeah, well, it was fascinating work, but we filed several patents, and I was studying AI and we didn't call it machine learning back then, we just called it AI, and I was studying AIs and I was looking for whatever, and basically at the time it was way too early for all that stuff. But I really was across all the statistical algorithms and the statistical methodologies, and a thing that we call expert systems. And there was a lot of value in expert systems. So expert systems are rule-based systems, and you're using them all the time. You don't even think about it. But an expert system is a system that you put something in, and it literally says, if this, then do that. If this, then do that. If your logic is if this, then do that, and there's lots of data involved, then it's an expert system, right? So a lot of things that people call AI and machine learning are just really systems. So we wrote
with a real heavy focus on network assurance as opposed to just general purpose AI.
Well, this was expert systems, and it was all around analyzing customer data. And so we had, at Cisco, I was working in a team that was called the NSA team. It became called Advanced Services, and I don't know, it's got a new name now. And they were collecting data off all the customers' networks. Customers paid them to do this. They bring it all, upload it all over the internet to the Cisco backend, and then we had all this data in these servers. And this is lots. It was huge amounts of data. So we had it in Oracle 8 databases, and we had access to it. So I wrote prototypes and stuff to take that data and do things with it. So I was applying, the basic job that I was doing was taking, network engineering knowledge and writing code to encapsulate that knowledge. And we wrote the knowledge in XML rules, and then we wrote engines that read the rules and applied it to the data. Hence, it was an expert system. But the system was extensible because it was rule-based. And this is 2000. I designed all this in 2001, and then, went to California and then just rolled it out through Cisco. And it was a huge education for me. I went from working in Cisco Australia, which was maybe 1,000, 1,500 people, and everyone just got things done and everyone just made things happen, and there was almost no politics. It was all about the customer. Turned up in Cisco San Jose, 19,500 people on a campus, and 5% cared about customers. The rest just were trying to keep their jobs. It was like going to work at a huge bureaucratic organization because it was. But of course, Cisco in Australia was nothing like that. It was agile and lean and getting things done. And Cisco in California, there was a lot of good people, huge number of really good people there. There was a lot of people who just had jobs that just were obscure. Like there was a marketing team that marketed that department internally at Cisco. Like that was the day I just sat there and went, what the? So selling your ideas internally was harder than selling them externally. I learned so much about how to explain concepts to people. And one of the things I've always done is Silicon Valley was filled with people with death by PowerPoint, still is. So people are so used to turning up to a pitch and getting 50 PowerPoint slides and never seeing anything work. So I put all my stuff in PowerPoint slides because you had to. I'd explain everything in the PowerPoint slides and how it all worked. And then I'd say, great, do you guys want to see a demo? And they'd all look around and go, sure.
There's actually a working system, a working expert system. Yeah.
I'd open up my laptop and I'd bring up my text editor and I'd say, here's some Cisco router configs. You're all familiar with these? And a lot of the guys were network engineers. I go, yeah. And I go, okay, let's have a look at this. And I'd say, I'm just going to run the engine now. And it was all written. It was super fast. It was ridiculously fast. And the whole thing would run and generate the results in front of them. They'd see the screen fly up. Then I'd open up the HTML reports and say, okay, here's the results of all of that. Here's a best practices analysis of all those Cisco router configs. And, here's some reports off the syslog data. I just had all of that written. It all worked. And they'd all just sit there. It was just beautiful. Their jaws would just all be, their mouths would be open, right? They'd also be going, they didn't know what to do because I wasn't pitching them something that they had to invest in. I was pitching them something they had to use.
A slightly different mindset.
It was really different. And I see the similar thing at Opmantek today. We go and talk to customers and we're pitching them stuff, but what we're telling them works. And we get that same thing. So I don't like to do PowerPoints anymore. I like to just do demos. And so when the CEO, Craig, asked me to come on to calls, it usually means the sales progressed a bit and they've already spoken to the things. They've already seen some products. But when I do a demo, I kind of have a chat to them about what they're trying to achieve. And I go, so you'd be interested in these features? And I go, yeah. Well, let's have a look at those features. And then I show them and I'm able to, we've got a little lab network with enough equipment in it that we can cover off most use cases. So I can do configuration changes and I can crash devices and black hole routes and do all the things to make a live-ish demo, like show the features working really well. And again, you just get silence because most network management vendors can't actually show their products working like that. They don't work responsively and quickly. So, you go in, like one of the parts of the demo is I just go and I use our virtual operator system to just start downloading a file across the network, right? So I just tell the virtual operator, go run this download on that Unix server over there, that Linux server. So it kicks off a background job to download whatever it is, 10 gigabyte file from the internet, which generates traffic on the network. Within 5 minutes, there's alerts coming in through NMIS and into OP events showing the alerts. So I say, well, here, we're going to generate some traffic, see? And then I can show them the graph and show them the traffic. And, oh, here, the system's already detected that high utilization. It's detected errors on the interface. It's detected these things. Okay, let's have a look at that traffic. And I click the button and we either show them the net flow data or I show IP flow top talkers or, we just demonstrate. And again, we just get that jaw drop response over the phone. Like they just go silent for like, whatever it is, 10 or 15 seconds. And they're like, oh, it works. It's sort of it's a funny thing, but that's what I learned it was a big lesson I learned in California is when you're pitching things and telling things, a picture says 1,000 words. Well, the demo says 1,000,000, you got to show people it working. You can't, you can build trust and rapport and you can do all the credibility, all those things you got to have. You got to build all those things, but you got to show people something working. An idea is an idea until it's been executed. When it's executed, it's innovation.
The thing I love about that too, and I've experienced it a few times over my career, where a single individual with a single laptop can come in and demonstrate a solution with only just basically by themselves and within minutes, and they can demonstrate a working solution, as opposed to when the competitors wheel in 5 racks worth of equipment and 15 engineers and then take the next 2 weeks to customize everything to demonstrate similar sort of functionality. And just the power of the individual with such a small footprint technologically, but also just in the time frame that they take to get something up and running and demonstrating becomes incredibly powerful to customers.
Yeah, I think you've also hit something there that you've got this combination of out-of-the-box functionality and something, I'm not sure if I should name vendors or not right now that I'm
perhaps not
things about, but I've worked with some vendors and I won't name them, but I've worked with some vendors. They do have 3 letters in their names, but that's several vendors out there. So we were doing proofs of concept with these guys. A colleague of mine was doing a proof of concept. They'd done it like 2 months before at another company. And they came across to work with us and I said, oh, great. So how long will it take us to get that Cisco router added into your system? I think this was the example. Oh, well, it's going to take us a week to do this and blah, 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 blah. I said, yeah, but you just did a project with XYZ company and they just did that. So can't you just take what they did and put into your system? Oh, no, we're not able to do that. And that, to me, is the fundamental problem. So that means that the knowledge that you have, the system has a knowledge. The system has a way of working, a knowledge about how it operates. It's a set of rules. It's a set of policies, set of configuration, whatever you want to call it. That system had something configuration that they could not extract from the software. And so when they come into me and they're going to take a week to add that device and another week to add the other device, that's just BS, right? Like that's just not on. Because when you've gone to a customer and you've charged them services to do that work, and then your business model is to go to another customer and charge them the same money to do the same work you've already done with 10 other customers, then you're not in business to help the customer. You're in business to help your pockets.
Yeah, absolutely.
So, you see really strong software with good methodologies and good ways of development means that you turn it on and it works out of the box. Someone's paid at some point. So someone might have to pay once to have something developed. Then it should just be some knowledge that's then just added to the system, whatever it is, it's configuration. Or a really great example that's really tangible is Nagios plugins. People need to go and solve a problem. They use Nagios. It's a very powerful tool. They write these plugins and then you can just go and share those plugins around. Like that's an example. So you don't, by the way, NMIS eats Nagios plugin. So you can grab a Nagios plugin, use it with NMIS, right? Because it's become a de facto standard for doing stuff, right? It's a simple interface for talking about state and status of something. But when systems, like a lot of commercial systems, they're not after you to buy the software. They're after you to buy the services. So their software is intentionally designed to be complex and require 15 guys to make it work.
That's a big difference between a product company and a services company.
Right.
And generally, they stand out pretty obviously. You can usually pick a product company versus a services company by so many aspects, like the ones you've just described.
Right. And it's different. I think Xero showed us this in accounting. So Xero came along and just said, well, look, all this stuff in accounting is normal. This is all standard. This is all standard. That's, you might have some customized practices in your accounting over here. We'll just abstract all of that. And here's the key word, abstraction. So, I learned a huge amount about abstraction. I got involved, like California I had this great, lucky early career in Australia, doing all this work I was doing in the internet and learning the internet. And by the time I got to the States, I had more breadth than most of the guys that have been doing it for longer than me, because I just being in Australia, got to do lots of little things.
Yeah, you tend to be jack of all trades because it's a smaller market, much smaller market than the States, yeah.
Right, but then I met a guy who was, so I always thought this was funny, lovely guy, really knowledgeable. He was an expert in Cisco 6500s. And I asked your mother what other products he worked on. He said, nothing. I just work on 6500s. Now, he worked with American Express at the time, and they had like 1,000 of them. So he had a job with them. Like, he was a Cisco consultant, and he did a great job with them. But he was specialist, completely specialized. And here's a lot of the guys that I knew in the States doing the stuff I was doing were expats, probably from the colonies, right? So we were from Canada, we were from England, we were from Ireland or New Zealand or South Africa, parts of Europe. They'd all come over because they needed people with a bit more breadth. Depth is good. Depth is always good. Being somewhat important. Of a specialist, I think jack of all trades, specialist in a few is what I like to think of myself. You've got to have some depth in some things, but you need to have a bit of breadth. So that I was very lucky to get to the States with that knowledge, and then I learned more, right? Like, then once you've got that breadth, it's really easy then to extend it, because your breadth of experience then lets you multiply. So the concept that I introduced to the software developers, this is crazy, but I introduced to the software developers in the States, I introduced them to the concept of queuing theory. Now, this, of course, is how networks work, and you have to understand that, and this is what you do, and it's how QoS works, and so queuing theory. And most software developers don't understand it, and still probably today still don't. So I introduced queuing theory, and I designed all these messaging systems. So we were accepting, so I was involved in Cisco's call home system, and we designed the call home system where Cisco devices you would subscribe to the service, and they would send their messages, through the internet. They'd call home to Cisco services. Your spare fan would fail or whatever, and the chassis would report the fan failure to the vendor, and the vendor would turn up with a new chassis, a new fan. That was the whole point of call home. The backbone of that system was a messaging system that used queuing theory to queue the messages and handle the messages, right? This is back in 2002, 2003. And that was we call it breadth, but it's also diversity. It's diversity in your disciplines, lets you leverage experiences from each of the disciplines and build better systems. And that's the key, again, back to integration and data. It's all about data. Everything we do is about data. And anyone who tells you otherwise is lying. It's all about the data. How do you get the data? How do you look at, how do you store it? How do you get it back? How do you analyze it? How do you delete it? How do you summarize it? How do you manage it? All of those things. It's all about the data.
And how you make use of it. From those early days with NMIS, there was clearly a groundswell from the community to have survived from inception in 1998 through to the Opmantek acquisition in 2011. How far had the product come in that time in terms of features and functionalities, or maybe sizing, scaling, whatever it may be?
So there's a lot here to cover. I'll just try and summarize, because some of it's probably doesn't need to be discussed. But there was NMIS at version 4 was essentially feature complete. There's a concept in software development that I've noticed that by the time you hit the fourth version, the fourth major release, you're now up for a re-architecture. And you see it pretty consistently in lots of different things. So around about version 5, you need to do a re-architecture because you've basically hit the limits of a whole bunch of design and implementation assumptions you've made over 4 generations of your software. Right. So now you have to go and re-architect.
Well, and often even the underlying tech stack, those have really improved over the years as well. That you almost have to, instead of refactoring, you now just basically, okay, let's start afresh.
Right. And to the other thing is, by the time you reach the 4th version, theoretically, maybe you should be obsolete and not necessary anymore. So it was this funny thing with Opmantek and NMIS is that, so Eric he'd been working and looking at NMIS 5 and wanting to do some stuff with NMIS 5. So he'd been working on NMIS 5 with the NMIS dev team. There's a bunch of guys working on the NMIS dev team. This is all through the 2000s.
All on a volunteer basis. They weren't
volunteers.
Employed at this stage. Yep.
No one was employed. This is all pre-Opmantek.
Yep.
And they were kind of working on the next generation. So NMIS 4 was feature complete. I'd actually been doing some work. I'd gone back to Macquarie at some point, had done some stuff on NMIS, early version of NMIS 4. It was really solid. I'd sent all that back to the open source community. So I don't think it got picked up in a release, but NMIS did what it had to do. It was working brilliantly well with Cisco devices. It was relatively easy to make it like the dev team could easily add device support, but we knew its limitations. So there was a series of limitations that we knew, and there was a series of bottlenecks and things that we wanted to fix, and that was the re-architecture time, right? That was NMIS 5. That was what Eric had started working on. And then, unfortunately, Eric was unable to complete that work for various reasons, and Danny came along and wanted to do Opmantek, and they're doing, well, open source looks good. So he said, let's do open source and let's do NMIS. So then Danny basically acquired the intellectual property for NMIS from Eric and I, and then set up Opmantek. And so by this stage, Eric had got back involved again and, had most of NMIS 5 was basically working. And then we basically launched in so Opmantek's 10 years old, by the way. April of 2011, Opmantek launched, and there was NMIS 8 for some reason. We decided that 8 was a good number, and we released NMIS 8, and it included these new concepts around modeling and different ways of doing stuff and extensibility and fully object-oriented. And there was just a whole lot of stuff that changed in NMIS 8, and that was the next generation of the technology.
Was Eric he was also the author of Open Audit, another open source tool? That's Open Audit's with Mark Unwin. So Opmantek started, and then later on, 2013, I think it was, Opmantek acquired the Open Audit project and Mark joined the company. Got it.
Eric's never worked for Opmantek, but his son, James Greenwood, works for Opmantek. Yes. So James first came to my house when he was a teenager, and then, now he's one of the dev team and does an amazing job.
So was Opmantek always planning on building around an open source core, but then always planning to basically enhance those free tools, but also build value-add tools and expand on support to bring more of a commercial operation to things? Was that always the intent from the outset, or was it originally planning on just going down the open source and continuing to develop the great tools you already had?
So I think maybe Danny's and my memories are slightly different about this, but I remember many discussions about this, and I'd said to Danny many, many times, people want more than NMIS, right? So my brother and I had discussions about NMIS being the basis and then doing all these knowledge-based tools on top of it and, whatever. So I'd had these high-level conceptual things in my head around something called NMKS, right? Network Management Knowledge System, because there's this whole thing around data, information, knowledge, and wisdom, right? So this was something I was reading about and understanding quite well. So I'm a big fan of knowledge capture, knowledge reuse, all that sort of stuff. So, in my mind, we were absolutely going to sell NMIS support, and there was a lot of people out there using NMIS, and we thought they'd buy NMIS. But I had said to Danny, and maybe he's forgotten, but I said, people will definitely want reporting modules, and they'll want other modules, and they'll probably want to do configuration backup, and they'll probably want to do NetFlow and stuff. Because, I've been a network management consultant, and I've done all this stuff over the years. While I was at Cisco, before I left, I was actually a network management consultant and a data center consultant, a data center architect, enterprise architect. So when I was doing all the network monitoring, I knew very well all the FCAPS model is excellent for enterprise. And, OSI, I did a lot of TOGAF stuff, and, you got the whole assurance management stuff fits in really nicely. NMIS, our stuff fits in really nicely in the service assurance area. So basically they're functional things. So people want to solve those problems. They're functional capabilities that an organization must have are those functions. They must have reporting. NMIS had a very basic reporting engine. It worked, but it was very basic. NMIS has a decent visualization system, and it's quite good, but, people, need more than that. They want more than that. So I knew that people would want things in addition to NMIS that would make, do more with the data. We hadn't really figured out how that looked at that point, but I knew that they want, and very early on, we got this deal with Telmex really early, way before we should have in a company's, start. And that's that long tail of NMIS. That's someone. And
tell us a little bit about Telmex, for those who don't know Telmex.
So Telmex is Telecom Mexico, basically.
A tier one telco.
Tier one telco. I think they've got something like 300 million mobile subscribers or something like that.
Just a little network then.
Yeah. And Telmex had some ridiculous number. And I think it was something like 30 million home internet subscribers. So, of course, they do managed services and they have a CNOC, what they call a customer NOC. That team had been using NMIS4 for years because their products from another vendor maybe with 2 letters that one of them starts with H. So they were doing that stuff with that company and it wasn't delivering on the contract. So the crazy story is that that basically Telmex just said to that company, you must go and buy this open source solution to put in here, right? And then they did a trial with us and all the stuff that this other company couldn't deliver was delivered largely by open source and me writing some code very rapidly. So I think I wrote they wanted a mapping engine. I think I wrote a mapping engine on Friday afternoon and then delivered a Google Maps mapping engine that was reasonably functional, like basic, but functional in 4 hours.
So basically in the time it takes to record this podcast, you delivered a new product functionality.
Yeah. And then I had some reporting stuff that I played around with. So I kind of refactored that code. And I think that took me maybe a week or something to put together as a reporting module for them. And then, that gave us a framework for reporting. So then we just kept adding reports to that. And I'd had a Cisco IPSLA code lying around somewhere. So I kind of turned that into a Cisco IPSLA product and did all this responsively, as in responding to their needs. And that was where we kind of figured out pretty quickly that the modules would be an upsell. Because by this stage, we hadn't sold many contracts, but we'd come across this customer. And back in the early days, as any startup is, I was really still doing a lot of consulting work to keep everyone in salary, so to speak. So I was out consulting and working with people a couple of days a week and then doing my day job at night and whatever. And it was a interesting time, but I don't know how many hours a week I was working, but a lot. Yeah, so basically we'd figured out a lot of stuff during then, and we knew that people were pretty keen. I remember walking through a security. Gold Coast has heaps and heaps of conferences, right? So we're walking through a security conference that we got tickets for in early 2012. And I figured out by this stage that people really wanted a NetFlow module. So I'm like, in my head, I'm like, we've got to do a NetFlow thing. We had a mapping system by then, we had a reporting system, we needed NetFlow, right? And that fit into the performance management area. So in my head, I started designing it. I saw some things at this conference and went to myself, that's what it's going to do. That's how it's going to work. That's what it's going to look like, right? And then I think I wrote it that week after I started writing it and prototyping. And when you're writing in this agile way, you just, there's a saying from the internet that the internet was formed on rough consensus and running code, right? And that's how you have to, you can't sit there and design forever, right? You've got to kind of get some ideas, get some prototypes going, start doing some stuff, find the problems, fix the problems, find the problems, fix the problems. I mean, that's very much my style of solving problems. Now, you've got to do that and get amount of knowledge about what it is that the problem that you're trying to solve. And then you might stop and do a bit more design work, finalize a design, formalize a design. And then you should do your refactoring again early, right? You shouldn't then wait ages to do your refactoring because you've made a lot of assumptions. You should go back, check your assumptions, check your bottlenecks, do all that stuff, do some baselining and performance, where are your bottlenecks in your system, and you should go back and do all that stuff. So, that's been my rapid way of developing for a very long time. So I basically did that with what became our OP Flow module. I think that was early 2012.
So earlier on, you talked about contracts. So in those early days, were the contracts basically just a support contract rather than a product contract because you didn't have...
No, sorry. So we'd signed John Deere really, really early on. And it turns out, since talking with them, they're still a customer with us now for 10 years. They've been with Opmantek for 10 years in June, I think it is. They contacted us because they wanted to solve a problem. They wanted some basic support to just some services. They just wanted us to do some engineering to help them.
So it was a bit of customized product.
Well, no. So then Danny turned that around and sold them a support contract. Well, if you buy a support contract, we'll do those services as part of that. So we sold a support contract. I was then contracting as a network expert. And in fact, with a company here in Brisbane, I was doing a lot of enterprise architecture stuff. So I wasn't working as a network. I wasn't doing Opmantek work contracting. I was just contracting for hourly rates. Because that's what you've got to do when you're in a startup, right? You've got to have money coming in the door. You've got to pay your mortgage. We're not one of these startups. You hear about these. I've heard about them many times and I just sit there and wonder how it happens. But, we didn't have $100 million in the bank from some VC. We had very little money in the bank and we were just working, and we had some money, but we were just working and organically growing. Later Daniel went off to the Australian Small Scales Offering Board and got some investors, and that's when we could stop the contracting work. When that happened, I could stop contracting.
But I guess the other difference to some of those really, really well-funded startups is you actually had a product there too.
Right. Yeah, that's right. So a lot of the times you get those well-funded product startups and they don't even have a product. They just have an idea. They haven't even innovated, right? They've just got an idea. So John Deere came to us. It turns out they'd started using NMIS in 2002 or something really early on. They'd been using it for years to manage their network. They found out about us. We gave them a support contract for NMIS 4. Later on, they went to NMIS 8. And then, we're just working on helping them all the time. And they had great ideas. It was been a great, for me as an engineering, doing that CTO-y, engineering-y stuff. It was great working with John Deere because they had real tangible problems and they were quite reasonable and huge network, massive network. So we did help them with a lot of scaling problems. I remember walking through Chicago Airport, having this conversation with Jeff and explaining that, okay, we can optimize the modeling system. I can do this. I can get you these models. They'll collect less data. They'll optimize the way the data is collected. They'll be writing less to disk. We'll all be good. Right. So, designing or optimizing on the fly. But that's what I did, and it fixed his problem. So he needed to shave to get the scaling he needed. He needed to shave off whatever it was, half a second off each device, maybe a second off polling each device, half a second. Because, this is the scale is another whole thing. And that's probably the thing that Opmantek does is we scale ridiculously. And these are exponential problems. So when you're collecting data, if you collect, doesn't sound like much, but you can do the same numbers right now. I'm trying to vaccinate everyone in the world. If you've got to deliver, two injections to 20 million people, how long is that going to take? It's a really long time is the answer. So how do you scale that? What do you do? And that's the same sort of math that we have to do when we're polling nodes and collecting data, processing net flows, whatever we're doing. You have to, and you've got somewhere's a bottleneck. There's always a bottleneck. Even when you make it super fast, there's always a bottleneck, right? So, for example, the Bugatti Veyron, its bottleneck is actually wind resistance, right? So no matter how fast you're going, there's a new bottleneck. Their first bottleneck was get the engine powerful enough. The next bottleneck was, getting enough grip on the road. The next bottleneck's getting enough brakes to stop, and then you just got to keep solving the bottleneck. So, as you keep going through a system and optimizing it and growing it, you've got to keep just optimizing the bottlenecks or mitigating them or removing them. So, that's what we've done. Opmantek's done is all the stuff we do scales, and we scale. We scale a technology with a combination of more threads, more. So on a single server, you can vertical and give it more memory, more threads, more processing power, and then you can add another server. So you then go horizontal, right? Then you can scale it horizontally. And then some of our customers, they go and take the database, put it on a separate server, adds some extra performance. It's not a bad idea. So, you can scale it that way. So you can build like clusters and keep scaling. So that's the thing that we got from that early time was we got exposed to these big customers and we had to scale. Normally when you build software, you don't have to scale to like your third or fourth version. You're not scaling early, you're scaling later, you're right. You're dealing with small customers with small problems.
You're building functionality first and then scale it later. Yeah.
Features and functionality, and then you do the re-architecture to scale. We had the system working. We just had to scale it, right?
And it's an interesting story too there about John Deere. So having existed as a product for, I guess, 15 years or so, you must have already had a fairly large install base. Was it easy? Well, actually, first question is, how big an install base did you have? Did you have a feeling for how far it had reached?
We had stats from SourceForge with NMIS download. It was 100,000, 10,000, something like that. And
at the time of Opmantek's takeover or acquisition of IP?
Yeah, I'm trying to remember the exact numbers, but...
At any rate, it was a really large install base. So
yeah, and again, the assumption was that there was a pretty decent number of
conversion from download to use.
Right.
Yeah.
I've actually got a number here.
Oh, very impressive. You are a data guy.
2018. There was 50,000, but they did something with their stats and broke their stats. So there was actually like 2 years missing.
Right, yeah.
Yeah, no, more than that. There's a whole chunk of stats missing from that. So it was, there was a lot of people who had downloaded NMIS, right, in this sort of period of its life on SourceForge. And there was sort of spikes in that behavior of those downloads. They lost stats before 2004. So we don't have the stats from earlier.
So it's 6 years or 7 years of
we had
lost
stats
stats.
of about 7 years of stats, yeah.
Yeah.
And so that was pretty decent. And I knew people, I would still see people and meet people and go, oh, you're the guy who wrote NMIS, right? It didn't happen like on a daily basis, but it happened with some regularity. And, we knew that there was a lot of install base out there, and that's still the case today. But Eric and I were just solving problems and doing stuff. So it was kind of like the engineering tool built for engineers by engineers is what I've always said. And NMIS just solved problems for people. It didn't necessarily have some of the bells and whistles. It didn't have necessarily the prettiest GUI. So NMIS 4 GUI was just very functional and very basic, but it had these concepts in it that I introduced a long time ago around metrics and single numbers for metrics, and around having graphs over time for everything.
And I'm assuming you also really optimized for efficiency. Having been an admin yourself, it would have been optimized for efficiency rather than prettiness.
Right. It was efficient and fast, and it was you could start at the front page and drill into a node and be looking at CPU in 3 clicks. That was the goal. I wanted people. The GUI design was very simple. It was all CGI based, and you've got to remember back when we designed all this, big networks with 50 routers. So we quickly found some problems with this. Like when I was at Macquarie the second time, we had a network of 1,500 devices. So I'd quickly figured out a bunch of stuff and done different things over time. But I guess what's important is that the GUI was functional. I remember Dave Packham said one day in an email, he sent an email to the NMIS forum and he said, "Hey, NMIS dev team, thanks so much. You just saved the university and you saved my job. A boss just walked in and asked me why the campus, such and such a campus was offline. I looked at the NMIS dashboard and clicked once and it was able to explain to him what had happened." Thank you so much, because we had the information necessary for human to support decisions. Now, this is a really important concept. NMIS is called Network Management Information System. Information systems are an older fashioned concept from IT. Early in IT, you would have an information system, and information systems were there to support decisions. So an information system is what we call a decision support system. So everything that I was doing in NMIS back in the late 90s was all about writing code to support network engineers to make decisions. And that's why I put a thresholding system and an alert system into it really, really early. Because when you're at work all day, you want to get the email saying that something's broken, right? You can't. You're running around fixing people's things and working on things, and you get back to your desk and there's an email saying such and such is broken, right? So you didn't have to think about it. You just, got to go fix that. So that's a decision support system. You don't have to decide. You don't have to go look at a screen. And I get people, drives me insane. I get people, I want this thing on the screen. We're going to put it up on the wall, and people are going to look at it, and when it goes red, they're going to react. And I go, well, that's probably going to mean things are going to break and no one's going to notice. So you want action to be driven. You want activity to be pushed to the people who have to make that action, make that decision. You need the data turned into information sent to them so they can make a decision on what they have to do.
Actionable insight.
Actionable insights. I can give you a good example of this that John Deere did recently. It's really worth talking about in just in a second. And that's what I've always been doing, is just get the data. And so that's what NMIS 4 was really feature complete. It solved problems. It was efficient, very, very efficient. It scaled pretty well. Eric had worked on a multi-threaded engine, so it was actually scaling pretty well. You could do, I was doing like 1,500 nodes on a Solaris server. And you could optimize things. And there's a bunch of principles the way NMIS works, is don't collect everything. There's a lot of people who say, just collect everything and figure out what to do with it later. It's like, well, he's going to waste space and time doing that. Getting data and getting it to the people who need the data, that's what it's about.
To loop back, so you had, let's say, 50,000 customers already, or 50,000 downloads, people who'd already had a context around what NMIS was, all in that open source environment. So once you introduced the commercial overlay, was it easy to transition customers like John Deere over to the paid value-added products and services?
No.
So they've become used to having it as the freely available type product.
There's a lot of people using NMIS. So we got a call one day from a customer, a new potential customer. They said, "Oh, hey guys, hey Opmantek, we believe you've got NMIS. We've had an NMIS installation here for years. The guy who built it left a couple of years ago, and we logged in today and the servers crashed. Can you help us?" So I think
there are a lot of integrators out there actually putting it in and charging professional services for it.
Well, I think there was a lot of consultants, contractors, and there was a couple of guys who were involved in the community. So I knew this was sort of happening. So, and I was doing it, right? Like over the years, I'd done network management consulting and just gone and helped people out and grabbed a bunch of open source stuff and threw it together. And the thing about open source stuff is it's very robust. Well, at least NMIS is. So if you take a server and you put log rotation on, you do all these things the right way, you end up with an incredibly robust system. Full stop, right? So what happened was that NMIS was robust. It worked. And, damn it. So, people would come to us. Eventually something would happen. They go, oh, and the classic one, and this is where we made some inroads, is that one of our early customers was actually a guy who was at Macquarie, had been using NMIS over the years and, knew about the open source project. He went to another company. He remembered about NMIS. His bosses said, go get some software. He bought a solution from us pretty early on and we helped him out. It was in New York and we helped him out with that. And then he left there and went to another company and bought us again, right? So you had a few people like that who were around, just, they knew we had software to solve problems. So they bought software off us to solve the problem. And then,
so the product was so robust that there was no need for people to buy support off you.
Well, there is, because some people, when they wanted to scale, so this is sort of the interesting part, is that you didn't need to do it if you had a router, network of 50 routers, but if you had multiple servers. So one of the early modules that we got was a high availability module, what we call OPHA. And that was to combine the data from multiple servers into a single server. And that's what people wanted to buy. And that's what we figured out. I mean, we really figured this out pretty early on, that people wanted to buy. It was going to be the larger customers who needed multi-service, and they wanted the assurance. They wanted someone to call.
The safety net,
right? And when you stop and actually look at it, the magic number here is about 1%. You just need about 1% of the people to buy a solution. And that's actually what SolarWinds works on too, right? This is the freemium model. Is you have whatever number of downloads, you offer whatever it is that you're doing. Right. And I met the guys from Fruit Ninja and we were at the Export Awards together and I was chatting with them. And I remember saying to the guy, so how's your monetization going? The startup kind of conversation. And he said, oh, yeah, it's pretty good. We got 30 million users or 300 million users of Fruit Ninja. And I said, oh, and how many buy? And he said, well, we get an average of about 5 cents per user. But he wouldn't tell me how many of them purchased something. Right. But I bet it was just lots of them spent a lot of money. A few of them spent a lot of money. But, Fruit Ninja was one of the companies that figured this stuff out really early. You got to find that niche of value and that value add. And that's what I think we've done. Opmantek's figured that out in the last whatever years. I mean, we've been kind of evolving it over time. And to be honest, we get really busy, right? We win a new customer, you're just flat out helping them and supporting them and doing stuff with them. And then you go, great. And then you do a bit more product development. Then you get another customer and away you go again. And, and we've done lots and lots of releases. We have 2.5 million lines of code under management. It's a ridiculous stuff to do that we have to do. But we just iterate and keep moving forward. And we added a full-time marketing team 3, maybe 4 years ago. And that started to make a big difference. Like not having a full-time marketing team was a big impact. Once we got a full-time marketing team, that started to get us in the right direction. And again, just it's not one thing that you do. It's never one thing that you do. It's all the little things that you do add together over time and give you the result that you need. And you learn things like every time you're doing something, everything you do succeeds or fails. And the funny thing is it might fail now, but succeed later. So you've got to always keep that in mind. Like don't rush to turn things off, right? Just sometimes give them a chance to succeed. And also, just because something succeeds quickly doesn't mean it's going to continue to succeed. So don't just assume that you've solved the problem straight away. You've got to keep an eye on it. And every time something does eventually fail or doesn't pan out, isn't profitable enough or whatever you want to call it, but let's just call it fail, you learn something. You either learn that that's not good to do or you learn that you've got to change it to do it better. But then iterate on it and do it again. Iterate on it, do it again. I think we learned early that the customers that were going to give us money had a problem to solve. So John Deere, huge company, had no problem paying an insurance policy to a software vendor for support. Then over time, we wrote modules and we talked to them. By the time we went back to them, they're going through a renewal and we've written this module. Again, it got designed organically from a customer. Claro Dominican by this stage has signed up and, Monica down there rings me and says, I've got this problem to solve. And she describes this problem. And I said, well, we've been working on this trending analysis system. I reckon if I tweak that around a little bit, I could give you a dashboarding thing that you're asking for, So we pivoted that product and turned out what we call OP Charts, which was a massive thing for us. OP Charts was been massive for us. And so OP Charts makes NMIS better. And that's really probably when we started to hit the right formula. And that OP Charts was pretty late. That was what we called OP Trend, which then just changed into OP Charts. Started working on that in 2012, but just slowly in the background. Like it was just Chen and I back then. And it was chipping away and we were getting somewhere with it, just slowly. And then I think Mark had joined about this time as a full-time developer. And then things actually started development started to happen faster then when there was a full-time developer. And we had a flow module by then. We had some other modules, the reporting module, the mapping module. And then we did charts, and that was a new way of doing things. And it really changed things up. And we hit, maybe not the nail on the head, but we started to get the right nails. And that was that was really quite a big change for us. And we pivoted on some technology things there as well. And that solved some problems. And then we added a bunch of stuff into the charts module. And then we get massive compliments all the time from customers about OP Charts. It's got topology and dashboards and custom charts, and you can actually just include data from other systems. So you can just bring any data you want from any other system and just display it. So like a dashboarding, charting, cool thing that you just pull stuff together with, and customers love that, especially our MSP customers. They really, the managed service providers love OP Charts.
That doesn't surprise me at all, actually. But just being a really visual person, to me, that's one of the more important products in the suite. And so maybe that's a good segue too. Are you able to actually just itemize? So we've talked about some of the products that are in the Opmantek suite. Are you able to actually perhaps list them out and what they do for the listeners?
I can. So what I'll do is I'll just jump over to the website here so that I can refresh my memory.
A handy website. Yep.
Handy website. So I'm going
Opmantek.com, right?
Yep, Opmantek.com. And I'm going to click on products, all products. Products that we've got have evolved over time. So we sort of, Open Audit is an open source product that we have, which is audit and compliance, discovery, network discovery, and discovering everything that's installed on servers. And it's a very deep discovery, but it's there for audit. So it's very, very powerful. Does a lot of really cool things. And so we've got Open Audit Community, Open Audit Professional, and Open Audit Enterprise, right? That's your three products in one. You download one thing and you activate the features. So
and I'm assuming that discovery is also quite a deep discovery. So it's not just device and host name kind of thing. That's deep. Yeah, that's why we call it discovery. But so you're discovering. So that, again, all of our products do a level of discovery. So NMIS itself has a very deep, detailed discovery engine to find out everything about a device. You give it a device and then it discovers everything about that device that's interesting to NMIS, right? Open Audit does something similar. It does network scanning. So it scans a network looking for devices. And then if you've got the matching credentials, it will then collect all the detailed data about that device. And it works incredibly well with servers and Windows and Linux and HPUX and all the other Unix type servers. And it will work with your Active Directory, and it'll go on and do deep levels of discovery. It does lots of stuff with WI and WebM and so forth. So it's very, very powerful in deep understanding, but it also does lots of other vendor equipment, but it doesn't quite get the level of depth that it does with servers. So you get all the software installed, all the patch levels installed, all that stuff is Open Audit. That's what it's all about. Does it also include the scanning of the network and topologies and relationships, nearest neighbor, all that kind of stuff as well?
It includes network discovery. So it will scan your subnets and it will find all the devices on the subnets. It will find all of those things and it collects all the data about the endpoint. We've got some service management stuff that we do in the other products, which Open Audit sort of part of a solution around that. But we don't do like automated dependency analysis on the Open Audit data yet. It's something that we've talked about doing and we'd like to do. But yeah, we've got the data there. So we learn so you imagine all of your servers and knowing all the software installed and all the services running. We have all of that data. Open Audit collects all of that. So it could absolutely be used. You could add a graph database and say, right, what are the relationships here? You could absolutely do that.
All right. So yeah, Open Audit.
So then OP-config is our configuration management and compliance tool. You know, some people might be familiar with Rancid, but this is kind of like Rancid on steroids, and it looks good. You can start at the front of the GUI and you can put in a device name, put in show running config and go click, and you're looking at the running config. You click on compare with previous click. You're now comparing the last two, running configurations. You show run diffs and it just shows you the differences, right? It's super fast. And I'm not a marketing guy, but I'm probably maybe I'm a little bit marketing guy. It's probably faster than CLI. I'd probably welcome someone to challenge me on that I reckon I could probably, if it's doing its job, it's configured and running already, it's probably faster than someone going to CLI trying to find the same information. It is super fast. And you can, while you're looking at a running config, you can click the run, collect this command now. And of course, you're not having to do anything. You're not logging into anything. You're not running anything. The robot goes off and collects the command and brings it back and shows it to you and whatever. So there's a lot of capabilities in that. And the biggest capability we've added lately is virtual operator. So you can define a virtual operator job, and then that virtual operator runs against nodes, and then you process the data. So it's kind of like an abstraction for running stuff interactively from the device. So you can go troubleshoot. And the idea here is what we call operational process automation. So you can have a human that says, there's a problem here. They can go to the virtual operator, go run this troubleshooting thing on that device now. Is there a problem? And it'll come back and say, hey, the disk is almost full. The processes have stopped, whatever, right? And then you can click a button to restart the daemon, or you can click a button to take some action that you want to take on that device, right? So that's what OP configs. It's a very broad and deep tool at the same time. So very, very, very powerful. We're still supporting NMIS 8, and NMIS 9 is out. So NMIS 9 is the latest iteration. It uses MongoDB under the covers. And this difference between NMIS 8 and NMIS 9 fundamentally is because of MongoDB now you can see data. You can look at the data on the network at the same time. So it's not heavily sharded anymore. The data's in the database. You can do queries and say, show me everywhere where this product exists, or show me everywhere this IP address or this type of interface exists, right? So we do a lot of OSS support for our service provider customers. I don't think they've quite figured out NMIS 9 yet, because I think a whole bunch of OSS vendors are going to be very upset when they find out about NMIS 9. And the fact that you can have 20 million interfaces in a database and do a query on it in a split second and search it, that's what NMIS 9 does. That's what it does. And we do that stuff with our service provider customers, where they use us to do the inventory collection using SNMP. And then we export our data to their other OSS systems like Netcracker and whatever. And then they use it however they use it. So with NMIS 9, they wouldn't have to export it anymore. The data would be live, and they could just, hit the database and get the database. We've got OP Events, which is our event management module. It's a hybridized log manager and event management module. So it sort of has some really nice aspects of a log manager, but it has some powerful features of an event manager. And the most powerful part is probably that it's got like an if this, then that engine, that you say, if I see this event and this other property is there. So for example, if this is a high CPU load event and this is a core device, then do this, take these actions, right? And taking actions can be sending an email, changing the event, sending a syslog, opening a trouble ticket, pretty much whatever you can think of. But the big one it can do is it can go run commands on a device. So you see, you detected high CPU, so NMIS is polling everything. It detects high CPU load. It sends that event to OP Events. OP Events says, for those devices, for that type of event on those devices, go run this command. So it goes and collects the show proc CPU on a Cisco router and saves it with the event. So now when the engineer goes to look at the problem about the high CPU, the data they need to troubleshoot, it's there. They don't need to think about it. They just go, there's the high proc CPU. That's my problem. It's that process there is going crazy. We better go fix that. Right. So that when you go have those deep or those problems that happen intermittently, very, very powerful, super powerful capability. So, and it's very extensible, very flexible, but again, works out of the box. It'll process traps. It'll process syslog. We've got some of our trap processing customers doing a lot of trap processing with it in the service provider world, taking stuff from Nokia beasts that generate, thousands of traps per second. And we just put them through OP Events and filter out the noise and generate the events that are useful. And, it's multi-tiered. So you can have multiple layers of OP Events, and we call them polars, but, basically an event, OP Events running on the edge, running on a polar. And then you can have an OP Events primary. You can have multiple levels of OP Events primaries. So you could kind of summarize data as you go up, more critical stuff to the top and cool things like that. And integrating with service desks, like sending tickets to ServiceNow, whatever you're using, HP Service Manager, whatever you're using, Remedy. OP Reports is our reporting module. It's
actually, so just a quick one before you go on to OP Reports. We'll get back to that. So have you had much of an awareness of the if then else type rules that some of the customers have built, how funky they've managed to get, what interesting use cases they've gone and done?
Sometimes the customers share this with us, and sometimes it's later on that they share us with us. So the one that we were a bit more involved in more recently was with our friends at John Deere. So I was working with Hari. Hari sent him this obtuse email, or not obtuse, but, just sort of not very detailed. And he said, I'm trying to do this stuff with BGP stuff. I'm exaggerating.
That's pretty obtuse.
A little bit more detailed than that. But basically, and I said, Hari, we should have a chat. So we had a meet up, and what he was wanting to do, what he did, what he worked on, and what I helped out with a little bit, was that he wanted to do what he called WAN circuit monitoring. So he wanted to do something he first called validation. So is it really down? So the system has told me it's down. Do something to prove that it's down or not. That was really important. So he did this sort of validation step. Another really important thing he did then was to collect any supporting data, like go ping the node, ping the peer, go collect some data about the peer. And then what he did was do a whole lot of work around the metadata, so that as an event would come through, different events. So if a node down came through for what they call the WAN circuit endpoint, it would kind of be handled subtly differently. And then all of this resulted in an OP events dashboard, and it would send a trouble ticket to ServiceNow. And then the operators were always looking at ServiceNow, and they click on these particular events, and then ServiceNow would then open OP events, event context. We call it event context, which is all the details about an event. And present on that page then was, BGP neighbor down. This is the BGP service for this WAN service, which was a site ID, which was one of their offices. And all the metadata related to that office was there on the screen. And then it said, paraphrasing what it said, but it basically said it had proof that it was actually down and that the service was down, and all the data necessary for the operator to make a decision was presented to them inside ServiceNow. So the operator never left ServiceNow, but they had access to this rich, deep data about the event problem, all the things they needed to understand. So they abstracted. So for those operators, they didn't have to train those operators to be network experts. They just trained them on how to respond to these 4 or 5 different events that they came in.
Abstracted away all the CLI keystrokes.
The operator didn't require any access to do any of that. They could basically hire someone, train them. They didn't have to have any detailed technical background. They didn't have to be a CCNA, CCIE, anything like that. They could just say, when you see this, you're going to do this. And when you see this is bad, you're going to do this, right? So they gave them work instructions, and a lot of that was driven out of ServiceNow. So that's an example of using this stuff together and how they use that sort of combination of technologies together. So OP events was firing, doing automated actions to do some of those command collections or the pings or the trace routes, and then grabbing the data, saving it with the event. We've got another customer we've been working with who's a service provider in the US, and they're doing a lot of really cool stuff around MPLS troubleshooting. So they have this sort of concept of a shortest path and then the just get me there path. We've been working with them. So every day, they just want to check the network and verify if anything has failed over to the backup network, if you like, the just get me there path. And so we go around the network and we collect the commands off all of the routers that are involved in this MPLS edge network. And then we say, or the core on the edge. And then we say, what paths are you using? We just ask them. It's just commands coming out of Juniper boxes. And then we get that data out. And if we see that stuff, we raise an event, and we send the event along with all the command outputs in an email to the core networking team. So they don't have to troubleshoot. Like, we've detected the problem. It's in a failover state. Here's everything you need to know about the problem. Bang.
Which is often the problem when you're flicking tickets between different teams. They'll each go and do, more than likely, the same set of diagnostic tasks. Effectively, you're doing it all for them and putting it all there on the platter.
Yeah. This is what I call operational process automation. So depending on how your operations teams are, and I don't want to offend any operations teams out there, but sometimes your operators are trained monkeys and sometimes they're really clever people. Sometimes operations teams have a hard time with retention. How do you drive up the value, drive down MTTR when you're having a problem with retention? And the answer is automation. You've got to automate some processes.
Automate away the really boring stuff and let them solve the really high value problems.
Right. And maybe your high retention is because you're just giving them too much stupid things to do.
All the noise.
If you could, Proto's principle, if you could take the 20% of the things that are causing 80% of the work and automate it, that's a really tangible thing to do. If you could take 5% of the things that are causing 50% of the work, that'd be awesome, right? You just saved a lot of effort and time, and people can work on higher value efforts. Now, the other thing too is, and this is a big thing that came out of, so Poncho became, he's become a good friend of mine, And he and I had many conversations. I went to Mexico a few times and we had many conversations about things. And one of our conversations, he said to me, the problem I've got is in the operators, none of them do the same problem the same way. They all try and solve the problem in a different way. And then even then, one person will on a Monday will have the problem and solve it this way. And on the Friday, they'll have the same problem and solve it in a different way. And the customer's frustrated because the first time they solved it, they did it in 1 hour. The second time they solved it, it took 4 hours. And the customer sees that. So their customers get frustrated because they didn't mind that it was down for an hour, but when the same problem happens again, it's down for 4 hours, they get upset. So consistency, the big thing here is about consistency. What does this operational process automation bring? It brings consistency. Take that 10 or 20% of your problems that you're constantly happening, automate them, have them done consistently. You've just driven up the value for everybody, right? You've helped your customer satisfaction. You've helped improve the quality of your services. You've met SLAs, tick, 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 all the things that you want to be able to do. You've
improved employee satisfaction.
Satisfaction. You've helped your staff retention. You've just done all these things just by doing a little bit of process automation. What do we do in accounting? Just stop and think about this. What do we do in accounting? We automate the accounting processes. I used to work in this building society. There's this great big picture on the wall, and I asked the secretary about it. And I said, "Oh, what's this picture?" And he goes, "Oh, that's how we used to do the accounting." And I stopped and I looked at him and I said, "What?" He said, "That's me there in the picture." And Alex at the time was probably in his 60s. And he said, "That's me there in the picture." And I went, "Huh." And it was this massive room filled with men wearing white shirts and black ties. Just picture this old-fashioned sort of thing from the 50s or something. And they all had punch card machines, like punch tape calculators, or tape calculators. And he said, so someone would deposit money and the books would come up from the front counter and we'd go and take the book and we'd find the ledger the customer was in. We'd walk over to the wall, we'd get the ledger out, we'd bring the ledger down, we'd open up the ledger, we'd take the tape from the thing, we'd punch in the calculations, we'd take the tape, we'd stick it in the ledger, we'd put it back over on the shelf. Why do you think computers automated accounting in the 60s and 70s?
So that's where a lot of operation centers are today, but without the punch cards, right?
Right. They're doing things the way that manually. They're just doing everything manually. They're using computers to do what they do, but they're doing things manually, inconsistently, making mistakes. So the big thing for me is, when I was at Cisco, I was a network consulting engineer with a bunch of, really talented people, and we worked really closely with the TAC. You would say to the TAC engineer, and the TAC engineers would come to us for help, right? So they'd find out it's your customer. They go, "Hey, I need some help with this case." So we'd be working on these problems with the thing, and you'd often go to the guy and say, "Well, have you collected this information yet? You're solving this problem, but have you collected this information yet?" And then they hadn't. So now you have to wait hours for the information to be collected. And that's a problem that's always been in my head. So tools should always just do that for you. So again, when that CPU goes high, when that interface utilization is high, so classic scenario, you're running QoS across your network, you've got high utilization on your WAN interfaces. While it's happening, go collect the show policy map interface command. Save it into the thing. So when you're going to troubleshoot that problem, is the QoS doing what it's supposed to do? Simple.
Automate the diagnosis steps, because that's a big chunk of the time that's taken to resolve anything. Yeah.
Right. So now, is the interface utilization high? Yes. Is the QoS handling that? And you might need a human to decide that, or you might be able to process that. We've got plugins to process the command outputs. But let's say a human needs to look at it. They go, right, high interface utilization. Yep, I can see that QoS is working well and dropping packets. That looks great. We're good. Or they can say, no, the QoS is not handling it well. I should investigate further. And if the operator can't decide that and they've got to go to a level 2, level 3 engineer, the information the level 2, 3 engineer needs has already been collected. Because by the time they've escalated it to that engineer, it's the next day. And that the information that engineer needs is gone. So that's what this is all about. We've been doing this command collection thing with our platform for 6 or 7 years, and I've talked about it a lot. And, subtle change that we've had is we've put it together in this framework of, operational process automation, detect, diagnose, act. And the tool should do that for you, right? And they should give things to the humans to support human decisions. So that's what OP Events is about. It drives the action.
Yep. And I managed to sidetrack you there a little bit too, didn't I? So we were running through a list of the products.
OP reports. So
OP
we've got OP
reports.
reports, which is our reporting module. A lot of out-of-the-box reporting. There's some really fantastic reports. We've had a lot of customer input. A lot of customers have paid for custom reports to be developed, and then we just release them, right? So if they're not proprietary, the reports aren't proprietary. So obviously the resulting report is proprietary, but the way what they want in the reports is not. So we make a standard report, and customers want extra columns, so we have options. That's what OP reports is, and it's very powerful because it has a lot of the non-functional stuff done. So the report is generated, scheduled, automated, emailed to you, emailed to your customer, generated, dumped in a file system so that your other system, your OSS system, can scoop it up and add it to its capacity planning systems, whatever you want. All that's supported by OP reports. Lots and lots of non-functional stuff that's really fundamental in a reporting system is done by OP reports, as well as a bunch of really cool, useful reports for engineers to use to solve problems. OP charts is we sort of touched on OP charts earlier, but that's our dashboarding, visualization, topology infrastructure, like shows you network topologies. It's a diagramming tool, it's geographical maps. A lot of customers are loving it, really loving the diagramming. So you can basically do semi-automated diagramming, or you can do manual diagramming, but the diagrams are live, right? So the diagrams icons are your network icons, and you can click on them, and the lines will be color-coded to the utilization. If the link goes down, it goes red, all that stuff happens, and it's your topology, semi-automated or fully automated, and then it's live. The network diagram's live. It's color changing while you're looking at it. And it's got dashboarding. It's got a really granular RBAC for portals, customer portals. So a lot of our service provider customers and MSSPs use it to provide portals for their customers.
Mm-hmm.
Their customer logs into OP charts and click. They can see the stuff that they want to see. OP Flow is our NetFlow module. It does NetFlow, SFlow. And we've also got an OP Flow SP, which is it's the same product, but optimized for service providers. So just optimized for larger volumes. So typically enterprises want OP Flow, service providers want OP Flow SP. OPHA is our high availability module. Very, very powerful. The new version 3, you can actually use it for controlling your cluster, so centralized configuration management. So you can go to the OPHA server. You want to push out a configuration change to all of your polars. You go to that primary server, you put your configuration change in, and you push it to all the primaries, all the polars, I should say. And that's that, so really, really trying to drive forward, simplifying and making it easier to manage. Because, our customers Telmex has over 100 servers running our software.
Wow.
OPHA has really got a automated sysadmin, config distribution system built in.
Yeah, that's a big footprint, isn't it?
Yeah. It's there's a concept here that you solve problems, you be pragmatic and solve problems, and you don't need these massive bits of complex software. OPHA is download as 100 meg, and you can install it, and everything I just described works out of the box. When you want to add a polar, you install a polar, you install OPHA, you go to the OPHA GUI, you say add polar, you put the username password in, bang, you've added it. So all of the complexity, there's a duck swimming there. There's a whole lot of software doing a whole lot of work under the covers that just makes it really easy for the person to deal with what we call an NMIS cluster. So OP Trend is our trending module. It's very powerful. It uses the SEDS algorithm to do anomaly detection. And we've got some more additions coming to that around our dynamic baselining tool, which is something that we helped develop for John Deere. So it's a response to John Tahari's requests. We sort of added some what we call dynamic baseline tools. So that's a really powerful, super powerful self-baselining automated thresholding system that you can point at any metric that NMIS has collected. Mm-hmm. And that's part of sort of OP Trend. OP Address, which is our lightweight IPAM. I wouldn't consider it a full-blown IPAM. It's really IP address-based auditing, tracking, allocation. It doesn't integrate with DNS and stuff at the moment. It might in the future. It doesn't right now. But it's also a bit of a discovery engine, right? So you put into it all the details, and it crawls the network, and it uses SNMP to talk to devices. It gets the MAC address tables, the ARP address tables. It figures out what things are and maps all that together. And it'll find all your endpoints and tell you all about all those endpoints as well. And then we've got Open Audit Collector, which is a collector for Open Audit, obviously. So you can install Open Audit Collector on the other side of a DMZ, and then you can have Open Audit talk to each other through the DMZ. And OPHA works in a similar way too. You can have OPHA means you can have NMIS servers behind firewalls on the other side of firewalls and talking through firewalls.
It's a really extensive product list. And it seems to me, though, that still open source strategy's really been hugely influential in the success of Opmantek up until now. Have there been any really significant realizations around open source strategies that have come to you along the journey? Like, I know you've talked about a number of different pivots, small and large, but any particular strategies that or realizations you've come to around open source?
I kind of feel like I told you so is one of the first realizations. So when we started Opmantek, we were talking about open source. Danny and I were talking about open source and just telling people it's the future and it's the way to go. And I'd already been seeing it. I was so involved in data center architecture at the time, and I've been doing a lot of network management, obviously, for a long time. So I've seen the value of open source in network management. And I'd then been doing data center architecture, and I could see how much open source was being used by dev teams. And it blew me away. And I started looking at these new development stacks that people are talking about. And I went, wow, all this is just open source stuff. All of it. And so I wrote some blogs and stuff, and there's a couple on our website. And I did write one a while ago called Open Source and Chili Con Carne. Because chili con carne is kind of like an open source recipe. You know, everyone's got their own, especially in the US, everyone's got their chili con carne recipe. And they share it with each other, and the chili con carne gets better. And so that's what open source is like, right? You've solved a problem. So I said earlier, I said that I've never met Tobias, but I've exchanged emails with him over the years. And of course, Larry Wall, who wrote Perl, I think he's amazing, right? Like, I just think what he did and contributed. So they did all this stuff, and then it let me do what I'm good at and take what they did and build something on top of it. So there's that aspect of open source, and that's really cool. But the reality is that open source is now, 10 years later from Opmantek, open source is here to stay. It's taken over the world. What Amazon does is actually mask open source, and everything they release is actually just an open source project that's an Amazon sort of spin. And Google, everything Google does is open source, and they contribute massively to open source. There's a whole bunch of stuff that we now take for granted that started as open source projects, and Google developers developed it, then they open sourced it. So everything we do now, like your Android phone, is just open source. I'm using a Mac. Mac is open source. It's free BSD, and there's a whole bunch of stuff in that that's open source. Obviously, there's a proprietary stack there in places, but a whole bunch of what makes Mac work is open source. Microsoft's done a huge amount around open source. And all the time in the last 10 years, Linux has just got easier and easier and easier to use. That's a big realization for me. It's like, I told you so. Like, I knew this was coming. I saw it coming. I've been working with open source. I got my version of Slackware Linux in like 1994. I've been using SCO Unix, I should say, right back in the old days. And I just knew, I could just see how good open source had gotten better. And I'm a big advocate for GNU, right? GNU's not Unix. GNU is all the libraries, and people forget this. GNU is all the things that you take for granted on Unix. All those commands and things that you do are not Unix, right? So ls, rm, all of those commands are added on to Unix. Open source is there. You can solve any problem that you want to solve with an open source library, open source package, open source module, open source product. You can solve those problems. And I think I've always known that. Maybe what surprises me is how good open source is, and I shouldn't be surprised. I should be proud of software that I've written and everyone else has written. I've gone to people's sites and I've seen them. They've gone, oh yeah, we're running some commercial module, and they show me the commercial module and the software's crashed. And we've got software that just runs at our customers for forever, and eventually the server dies. It's just open source is just better. Now, the flip side of this, though, Ryan, is the elephant in the room. Then why has Opmantek got commercial software? Well, we have to pay the mortgage. We have to make a living. If people want, we will provide our commercial software under an open source license, a commercial open source license. And we've done that for some of our customers, where they've said, well, we love your commercial products, but we really like open source. No problem. Here's the license agreement we're going to issue you. So it's still open source. It's commercial open source. But you can still have access to the source code. You can still get what you want, but you can't give it to other people. That's the same. And whereas full open source, you can take this, everyone gets access to the source code. That's the big realization for me, is that how good an open source has become. And I don't think I think I wrote a blog about 6 or 7 years ago, and I think I estimated that maybe 70% of software that we do is open source. I think it's probably more like 90 now.
So one of the realizations that came to me is when you talk about having customers like Telmex for what's ostensibly a little company on the Gold Coast in Australia that didn't have a marketing team until 3 years ago, picks up a tier 1 telco that's servicing 300 million subscribers or whatever their subscriber base is. And I really feel like it's an indicator of modern marketing. So in the old days, you used to advertise, so that was a push marketing model. These days, I feel like people tend to tune out, they tend to filter out the push marketing models, that it's more of a pull marketing model. People go and do their own research, they download the tools, they start using them, and then internally, someone at Telmex obviously downloaded it years ago, said this is really cool, this can add value, let's actually bring that into our stack and build the business case and the business model around it without you ever having marketed to them. So to me, that was an amazingly powerful story. Do you feel like open source contributes in that way as well?
Oh, big time. I mean, it used to be a big thing. Like when I was doing some OSS consulting with Optus, I think it was years ago, they said to me, oh, can you help us with a build versus buy framework? I said, sure. I said, what about open source? And then I said, and I can't remember the details of what I did for them now, but I came up with a sort of a decision tree, COTS, commercial off the shelf versus, build, right? And then I helped them with that decision. And I think we injected some open source in there, but I did say to them, it's not just commercial off the shelf, it's open source off the shelf. And I think the difference that's big time that's happened with open source in the last 10 years, especially, is that open source has is really mature.
The trust level's gone up.
Trust level's gone up, but the sophistication has gone through the roof. Like,
true.
I would argue that the open source packages right now, are, in many areas, in a huge number of areas, are way, way better than the commercial packages. Now, this is going to continue on because more and more people. Now, you could argue that there's also going to be. I think the markets are fragmenting, and I've noticed with IT that there's more and more people going to boutique services and boutique service providers. So imagine that you're someone who wants to solve a problem, whatever that business is, and you've got a bunch of people that who want monkey washing services. So you can go get some open source software, build out some really cool monkey washing open source front end, get all your customers signed up, and you've had to do a really pragmatic solution. You've used a bunch of open source stuff, and you solve that problem quickly, and you've got your branding and your look and feel on it, and it's modern and it's good, and then you can support that for your monkey washing business. Right. And that's just something that you couldn't do before, because before, if you wanted a monkey washing business, you had to go and talk to 3 companies from Silicon Valley, 6 companies from Europe, and then buy some ridiculous CRM that cost $42 million that you couldn't afford.
And get an integrator in to pull it all together.
Right. Now, and here's the big one. Open source has enabled startups massively to start. Because now if you're an open source company, you can go, if you're a startup company, a lot of these startups are startups and they're selling software as a service. The software as a service they're writing is written on open source. So all they're writing is a monkey washing business on top of an open source stack.
And it's not just the products, it's all the glue as well.
Right. Everything they're doing. And now, of course, so we're seeing more. So it'll be interesting to see how this transpires, because everything, the whole internet now, the backbone of the internet that we use and rely on is all open source. And that's the application side of it. Obviously, now we know there's a big white box thing going on with networking, and I think that's going to keep going. There's some really super stable operating systems out there for networking. I'm not across them all. Like, there's many of them and they're very good. There's just so much going on in this area, and you can't stop it. Like, the guys at the big companies selling the big software that costs a fortune, they don't want us to know about this. They don't want us to be clever. They want to sell you the software that takes 15 guys to come in and install. They want that you have to buy their services.
Yeah, absolutely.
So that's different now. So now if you're an independent consultant, you can go and find an open source system and solution or a stack and help a company. All developers are doing this every day. You know your half a dozen stacks that you use, and you build a new application on top of it, and then you can support that, and you can maintain it and extend it and enhance it, and you can do all of that. And it scales. I'm not saying an open source, there's some bad open source projects. There's some bad open source stuff too. And there's some great commercial stuff. But I do think that as we go forward, the ultimate thing that open source brings is open data.
Also just the power of community and the innovation and long tail of innovation that comes from having a community contribute.
Absolutely. However, longevity of data is more important. So if I'm a company and I've got an application running and I've got data in that application, I'm invested in that. Now I've gone to a commercial vendor who's gone out of business. What do? I'm gone, right? If I've got open source, I've at least got full access to the source code. I've got full access to the data of course. So now I can decide, do I want to get rid of that vendor or not? Like that open source solution, if that project, if the community dies, right, or Oracle buys them, or something happens, it's my data. I've got access to it. I've got the source code. I've got the database. It's my data. There's a lot of companies out there who've gone to a commercial solution and they're stuck. They can't get their data out. And they've gone, or worse, they've gone for software as a service. The data's in the cloud somewhere, not even on their own computers. They're going to be paying that vendor forever. So open source is about freedom. Open source is about freedom of choice. It's about freedom of data. It's freedom of community. It's all of those things. I'm a huge advocate for open source, obviously. I'm a huge advocate for open data. And I'm a huge advocate for the ability to have control, because there's something going on in the world where people from a certain valley in America think that they own everything. And they think that as soon as you put data on their computers, it's their data. And they write license agreements that affect. And we humans accept that, and we shouldn't. So we need to take control of our data because it's our data. They can't just take it from us, right? So anyway, as a business, running a business, you've got to be really, really careful not to lose your data. Just to get it back is a massive, massive effort. And just because you have the servers and they sit on your premise doesn't mean you have access to the data.
Yeah, absolutely. So we've definitely had a really broad-ranging conversation, and coming towards the end, I know that you're really, really passionate about tech innovation. That's come through really clearly. But also, really importantly, you just mentioned the word pragmatic, the pragmatic use of tech rather than just for the sake of it and being at the bleeding edge. Are there any particular technologies, products, concepts that we should already be using, hold great promise in the future, or that you're really excited to play with but haven't had the chance yet?
Ooh, I've been so busy for the last couple of years, just doing the Opmantek thing, that I'm up with lots of tech, but I'll have a stab at some of these things. The first one is that you can't underestimate the power of data, as I've said, and the importance of data. And what's really powerful, these terms are funny for me, but machine learning and let's call them data analytics systems. There's some really amazing stuff that you can do with data analytics, and all that stuff is out there. It's all open source. Almost all of it is open source because that's the community. They're all mathematicians. They're all scientists. That's who's doing all the innovation. So that's huge. That's something that you need to spend time on, but you've got to be pragmatic with it because you could spend a lot of time and not get results. So
now, you're already touching on that, aren't you, with some of the things you're developing in the Opmantek roadmap?
Yeah. We've got some machine learning-y kind of things. We're looking into machine learning and AI technologies and trying to understand how we can do more of that and how to scale it and all this sort of stuff. Because scalability, the big thing is, exponentialism is a problem. So it's a problem. So people forget, it's not a problem to have 86,400 seconds in a day. But now if you've got 7 days of 86,000 seconds, you've got a lot of seconds. We collect data every 5 minutes for every element on your network, and we store it in a disk. So that ramps up really quickly to millions and millions and millions and millions of data points. So when you're trying to analyze that, you've got to find really scalable solutions. So net result is those technologies are coming a long way. The use of GPUs and that is obviously, that's just moving forward massively. And I think you've got to be spending some amount of time and effort in that area. You've got to be looking into it and understanding it and understanding what you can do with your data to make use of it. And to me, the solutions around those technologies are just blending it with expert systems. So blending of if this, then that, and artificial intelligence / ML, where the ML is helping you look for something, spot something, then you verify it using an expert system, right? That kind of blending of technologies, like a pragmatic approach, not trying to boil the ocean. Like people say, just pour all the data in and run some stuff on it and the AI will tell you what's going on. That's just bullshit.
Yeah.
So I think that's the first thing in summary. And I want to get to some other ones. Big data is not dead. We don't hear about it marketed all the time. Big data's kind of got rolled into that AI ML. You've really got to know about your data and what you're doing with it and how you're going to manage it and how you're going to scale it. Data lakes are kind of a funny thing. Don't just pour all your data in. Understand your data. So big data's here still with us, and it's something that you've got to do. And that NoSQL, that big data / NoSQL movement is massive. And now we've got these column data stores letting us do more with different types of data. And you've got to choose the right database for the right problem. So you might be using column data store for that part of your data. You might be using, a document data store like MongoDB or a real-time database like Redis. Depending what you're trying to do, you should be doing that. And that's what I would call a pragmatic solution. Don't just say, well, I've used Mongo, so I've got to keep using Mongo. Mongo didn't solve some problems for us. We've just added Redis to our stack.
Or try and put time series data in a GraphDB.
Right. Don't do that because that would be bad. Don't try and put time series data in an SQL database. It probably won't scale for you.
Yep.
So, use the right solutions for the right problems. And that's pragmatic. Like I see people learn how to use a screwdriver. So they just see the world as a bunch of screws, right? Sometimes you need a hammer. Sometimes you need a nail, screwdrivers, drills. You need all of those things in your toolbox. On other tech fronts, open source is opening up in all sorts of other areas. So all sorts of other areas of embracing, and people are understanding open source and then doing all their own thing obviously we're IT nerds and OSS and all that sort of stuff, but there's a lot of other open source solutions in all sorts of different areas. So I'm involved in some conservation volunteer stuff, and there's a lot of stuff out there around CRMs that are in open source projects, and there's a lot of companies out there making a lot of money out of that stuff right now. And I think that will see people figure out companies can probably go and invest an amount of money in a development team to go and back a really good open source CRM and spend less money than they might be spending with a large vendor. And that will happen because that's where we're at now with open source. That's why open source is so good, because big companies, huge companies like Google have done that. They said, let's not buy, a solution, commercial solution off someone else. Let's just write what we need. Oh, by the way, let's make it open source after that. Lots of companies, and Amazon's doing this, Google's doing it, Facebook's doing it. And, and this is happening on a smaller scale too, right? So lots of companies out there support open source by having a developer work on open source. And Opmantek does that. When we find problems in open source projects, we fix the bugs, we upstream the bug, right? We extend if we need to, we extend and fix other open source projects. We try to get involved in those little communities. And sometimes the communities are 5 people, sometimes they're 500 people, right? But we'll help out and we'll get involved because we're making use of it, right? So we want to contribute back to that community. As far as other tech goes, on that pragmatic side, I think there's something going on in the world now where I'm just going to say Silicon Valley just keeps trying to sell us faster things. We don't need faster things. We don't need 8K screens. I don't need an 8K screen. My home theater isn't a 82 by 82 meter wall, right? Like, what size screen do you need 8K? So I don't even have 4K at my house, but maybe I could justify 4K, right? But 8K, why do we need that? I've got a very powerful MacBook here, and I'll probably have it for a really, really long time because it's more power than I need at the moment. But it's when I'm doing some dev work, it gets a bit of a workout. My old Mac, the Mac that my daughter's got, is 3 or 4 years old. It's super powerful. It does everything. So we're getting sold a lot of hardware and stuff that maybe is more powerful than we need. I think we've got to be pragmatic about what we need, and I'm really looking forward because I'm concerned about the environment. So I'm like trying to buy things now selectively that last a long time, because I don't want to have to just buy something and replace it in 2 or 3 years. So I'd rather go buy something that's more powerful, buy that bleeding edge thing now, and get that full 5 or 6 years out of it. Buying a new whatever every 2 to 3 years is just bad. That's just consumerism, and that's just bad. So I think that technology thing, you've got to ask yourself when you look at technology, is it going to help me? Is it going to benefit me or my business? Is it actually going to add value? Am I just trying to play games? Am I just trying to kill time? Why am I really interested in this technology? So you've got to be pragmatic about it, and you've got to sort of understand, how you're using it and what you're doing with it. And I think that's a really important general thing with technology is what's the value that it adds. Can we buy something or implement something that lasts for a long time, right? And just buying the latest tech isn't always the best thing, right? Investigate the technology, understand the technology.
The insights you've provided today have been brilliant. Thanks very much, Keith. I really appreciated the wide-ranging journey, and I've been fascinated to watch the journey of Opmantek since we first met. It's actually getting close to 10 years ago. It's been really, really interesting to see the success of a company up on the Gold Coast tackling some of the behemoths of the world. Thank you very much for coming on to the podcast. If people want to continue the conversation with you, where can they find you?
They can find me at opmantek.com. So my email address is Keith, Keiths, at Opmantek, OPMANTEK.com. And of course, I'm on LinkedIn. LinkedIn's KC Sinclair on LinkedIn. You can find me.
Perfect. I'll include that in the show notes. So thank you very much again for coming on, and thank you also for the audience who've been listening in on this podcast, and we look forward to bringing another one in to you soon.
Excellent. Thanks for inviting me along today, Ron.
Thanks for listening to the Passionate About OSS podcast. You can find more episodes, more than 2,500 blogs, and our contact details over at passionateaboutoss.com.